Alright, welcome to lesson 8-6, the zeros of the quadratic. We've already talked about the zeros as well as the name roots. So we're going to do the zeros of the function, and we're going to learn how to do it not only by graphing like we've been doing before, but factoring as well. So factoring is coming back into play today. So it says in exercise 1, consider the quadratic function here with the graph being shown right here. That's the same graph, okay? What are the zeros, part A, and then write their values and circle them on the graph. So let's do the circling. We know the zeros are exactly where it hits the x-axis here. So I'm not going to circle that. The circle's right here, and right here are the two zeros on the graph. Okay. What are the x values? Well, the one right here is a little bit. It's -1 to the left, and the other one, 1, 2, 3 to the right. So your two zeros are basically at where an x is equal to -1 and x is equal to 3. Those are your two zeros. Verify that the positive zero is correct by showing that y is equal to 0. So we're taking the positive one, the 3 here, and let's throw it in the equation. So if I go back to the y equals x squared minus 2x minus 3, and I want to verify that y is 0. So I'm going to put a 0 in for y. And let's plug the 3 in. The positive value is what they asked for right here. So 3 squared minus 2 times 3 and then minus a 3. So I get 0 equals 9 minus 6 minus 3. Of course, 9 minus 6 is 3 and 3 minus 3 is 0, and it proves out. All right, let's go to finish off this exercise with a couple more questions. All right, part C says to factor it. So we know we want to do the AC method. Our A is equal to 1, our B is equal to -2, our C is equal to -3. If I would do the X box, the AC would be 1 times a -3, so that's -3. And my B, of course, is -2. So we want factors of -3. The only way to get 3 in that is 1 times 3 anyways. So we got a 1 and a 3. And I want one to be, the bigger one to be negative. So does 1 times -3 equal -3? Yes. And do they add up to -2? Yes. So we bring down our first term, the x squared. We leave some space, bring down our last term, the -3. And then we take our pair in the middle from the x box, if you're still doing that method. And so I've got a plus x, and I've got a -3x here. Factor by grouping, what do they share there? Well, they share an x. I haven't factored it out, I'm left with x plus 1. On this pair here, they share a -3, so I pull it out and I'm left with x plus 1. So what are my factors? X plus 1 is shared by both, and the stuff on the outside, the x and the -3, is the other pair. Okay? So those are my two. If you remember, we take the opposites here, so one factor here is a -1, and one factor right here is a positive. Okay, so those are the two, at -1 and at +3. Now in part D, they want us to do the same thing, but with this equation. So, same type of thing. My A is 1 and my C is -10 right here. So I do my AC method and do the X box here. 1 times -10 is -10. My B is 3. Okay. What factors of 10? Multiply the 10 and they go to 3. Let's see what we got here. Of course, they're going to be 5 and 2, and I got to multiply with -10, so one will be -2, bigger one. Got my pairs, so bring down my x squared, bring over my -10, put in the 5x, put in the -2x. Those are my pairs from the x box here in the middle. Let's factor by grouping. You get x out of there, left with x plus 5. And on the other one here, a -2, and that will also be an x plus 5. So my pairs turn out, I'll bring it over here, turn out to be an x plus 5 times then an x minus 2. And my pairs turn out to be the opposite. So the opposite of 5 is a -5 is 1, 0, and the other one's, the opposite is +2. And if you check your table on your calculator, actually punch this into y equals that, you will find those and verify they are your roots. All right, what we're going to learn here is the zero product law, and all that means is basically when you multiply two things together, like an a times b and is equal to 0, one of them at least has to be a 0, so either the a, the b, or both. Okay, so what we're going to do is when you go and factor, we're going to go back to factoring like we did, and set equal to 0, you're going to get down to this step right here. Well, if you get down to that step, it's pretty straightforward. All you have to do is set both parts equal to 0. So I set that x plus 7 equal to 0 because that one equals 0. And I set the other one. We call that teeing it up. So I set both pieces equal to 0. And you solve. And so I just move the 7 over by subtraction. And x would be equal to 7 in this problem. And I move the 2 over, the opposite is adding 2. So the thing is x equal to 2. We know this by shifting because if it's set up like this, don't we do the opposite of 7, which is negative 7 here, which I forgot to write down. And the opposite of negative 2 is a positive 2. And those are my two roots that we look at. Same thing this one. It's already set up. So tee it up. They're already factored. So set 2x minus 1 equal to 0. And set 3x plus 4 equal to 0. Move the 1 over by adding it first. So 2x is equal to 1. Divide by 2. And one answer, one root, 1 0 is called a half. On the other side, move the 4 over first by subtracting. So 3x equals negative 4. Divide by 3. And the other root is called a negative 4/3. They may not come out nice, but that's what we do. So once everything's factored, the bottom goal here is we tee it up, and then you get your solutions. So as I alluded to, we're going to take the zero product law now, and we're going to factor. We get an equation like this. We want to find the roots. Yes, you could throw them in the calculator and see what they are right away, but they're going to ask you to do it algebraically. You got to be able to factor. So I'm going to go and factor this one. So if you take a look at this problem right here, of course my A is equal to 1, my B is equal to 4, and my C is equal to negative 12. Okay, so if I'm using the Xbox method, the AC part up here is 1 times negative 12, so that's negative 12. My B is equal to 4. What factors of 12, when I multiply them, basically add up to 4. Actually, subtract the 4. So I need a positive 6 and a negative 2. They make negative 12. So x squared comes out, the minus 12 comes out. Bring your A and your C's down there. Bring the middle pair in, so plus a 6x. And a minus 2x. Factor by grouping, I pull out an x, and I'm left with x plus 6. On the second one here, I pull out a minus 2. I'm left with an x plus 6. So when I'm done factoring here, I got an x plus 6. And I've got a x minus 2. And that, of course, is all set equal to 0. So now here's where the new part comes in. All we do is tee it up. So x plus 6 equals 0. Which means when you move the 6 over, one answer is negative 6. And the other one is x minus 2 equals 0. So when you add the 2 over, you get positive 2. And those are your roots. I'm going to do the same thing for B here. The interesting about B here is if you're doing it, you've got an A is equal to 2. And you guys start doing all this stuff. But wait a moment. You forgot always to check GCF first. What do they share? Bingo, they share a 2x. So I'm going to pull out a 2x. I'm left with x, and remember to divide them both, and I pull a 2x out of the minus 14. You're dividing by 2x, remember. You get a minus 7 equals 0. AC method not needed. It was just GCF only. But they're factored. I got two pieces too, don't I? So tee it up. Set 2x equal to 0. X minus 7 equal to 0. I'm sure you're okay with this one turning out to be positive 7. But a lot of kids freak out on this one. Big deal. Say, oh, there's no answer there. Yeah, there is. Divide by 2. What's 0 divided by 2? 0. Can't the darn thing cross at the origin? Of course it could. So there is a good answer. All right? All we did is factor it, tee it up, and you got your roots, also known as your zeros. a minus 4, and a plus 2. Okay, I'm not going to show the actual X box here. Factored by grouping, so I will get, on this pair here, I can pull out an X, and I'm left with X minus 4. On the second pair here, I can pull out a 2, so I'm left with X minus 4. Going 0. So I get 3 times, and then my one pair is X minus 4. They're sharing in both. And the other pair is the parts out in front still. Remember, I'm factoring, so that's an X plus 2. And it's equal to 0. And we're ready to tee it up. Now this I call a triple T. You actually have to set the 3 equal to 0 right here. X minus 4 equal to 0. And the last part, the X plus 2 equal to 0. This one turns out to be obviously a negative 2 when you move it to the other side. This one turns out to be 4. And does 3 ever equal 0? No. We actually reject that one. So I write reject. That doesn't even make sense. But you may, if you pull out an X out in front, there could be another root there. So talk about that in class. So now, I just throw that whole thing in the calculator and take a look at your points. You first of all know you're going to have one that crosses at 4. So I have a point somewhere right there. And I have one that crosses at negative 2. So I have something there. I know it's a positive, so it's going to be right side up, but I just get a few points off your calculator and plot them. One of which you could always do the axis of symmetry, which is that negative b over 2a type thing. But it's just as easy, like I said, throw it in the calculator. You'll find that, because you know halfway between those two is at negative 1 here, and the axis of symmetry is coming right down the middle here. It actually hits at negative 27. And personally, those are the only 3 points I need to sketch this baby. I'm good to go. All right, but the bottom line is factor these babies. Tee it up is your new thing. That's the zero product law. One of them has to be at least equal to 0, if not both in most cases, and we go from there. All right, see you in class. I forgot to tell you in here, before in class here, go back to page, to exercise 3, and do, what is it, C and D. Okay, I want you to do those two. All right, that's what we like. Talk to you later.